A warm welcome. This is Electric Energy Generation Utilization and Conservation course with lecture 5.1 focusing on house wiring. Normally, it's the domestic utilization of electrical energy purely means the wiring. Here we have different types of wires and different types of wiring systems and what and all the patterns in which the wiring can be made. All these cases will be studied in this video, and you can also consider a complete entire plan of a housing system and this wiring structure finally. Let us discuss about the different color types of wires. The electric power line which enters our house through three wires. It enters through the house through three wires, namely a live wire, a neutral wire and an earth wire. To avoid confusion, we follow a color code for insulating these wires. Actually, the red color wire is a live wire, black wire is a neutral wire, and a green plastic insulation will be provided for the earth wire. Different types of electrical house wiring systems. These include fleet wiring, casing and capping wiring, batten wiring, lead sheet wiring, and conduit wiring. While considering fleet wiring, this wiring comprises of the PV insulated wires or ordinary VIR, which are braided and compounded. These are the different types of electrical wires and cables. Those standard names, the communication cables, coaxial cables, hardline coaxial or a helix cable, direct buried cable, non-metallic sheet cable, metallic sheet cable, armored cable, metal clad cable, then multi-conductor or multi-core cable, paired cable, portable or extension cord, ribbon cable, etc. All these cables or wires are used application specifically. And while you are considering the requirements of a wire, we can use type used to RHH or RHW2 copper conductors for using raceways installed underground in wet locations. Also, type UFB underground feeder cable has a broad range of usage. From the National Electrical Code, Article 340, we came to know about it. For underground, we can use this. And this may be installed as an interior wiring in wet, dry, or corrosive locations. And its temperature should not exceed beyond 90 degrees. If it is a standard or solid one, then the requirements are based upon purely the applications. There are two main feeder lines. One is the main feeder and the next one is the panel feed lines, feed wires. So these two feed wires are main, others, it will be the main one through which the corresponding wires are being connected. Next, let us see about the sizing of a wire. The wire size is measured in American wire gauge. The American wire gauge number identifies the size of the conductors. The smaller the number, the larger the diameter. For example, if it is AWG0000, then it is 0.46 inches. If suppose AWG is 18, it is 0.04 inches. And the NEC defines the process for calculating the wire size based upon the current voltage and the length of the wire, obviously, because the current wire and the length of the wire will be determining its resistance value, and hence the size of the wire can be determined from that, because R is equal to rho L by A. So rho is nothing but the resistivity, L is the length, as well as A is the area. In order to obtain the resistance value, you can use the current and voltage parameters. From this, the area, that's the wire size, can be calculated. Next, the changes in the routing may require a change in the wire used to cabinets or field elements. Most householding wiring is usually using 12 or 14 AWG wire size. Dot signal, lighting, ITS wires, they range from 18 AWG for communications interconnect to 00 plus for power service. AWG hash wire can be either solid or stranded. It's purely dependent upon the application. And how to find the number of circuits in a house? 50 years ago, a kitchen might have been served by a single electrical unit. But today, a newly installed kitchen with the standard appliances requires at least 7 circuits or more often. So it purely depends upon the number of appliances which we are going to use in a house. The kitchens must have at least 2 to 20 amperes, 120-volt small appliance circuits are serving the receptacles in the countertop areas. Because we used to have toasters, electric electric stoves, and induction stove, and then mixies, grinders, refrigerators, etc. All these will be accommodated in the kitchens. So this is what is the thing. And so depending upon the requirement of any rooms, we'll count that number of circuits for that particular room design. And next is insulation and jacketing. How they are identified in standard specifications is XLP or XLPE. There is a cross-linked polyethylene. Moisture, it is of moisture resistance, it is flexible, and it can be used in wet environments. So that type of insulation can be used. Next is the thermoplastic high heat resistance nylon. Heat and water resistant nylons can be used so that it can be suitably comfortable during both dry as well as wet locations, where high thermal stability is needed and where high strength is needed. In those cases, this THHN or HHW can be utilized. And next is the PVC. It is a low heat resistance. It is not resistant to sunlight. If it's not appropriate for wet locations with and low flexibility area. Rated for wet location in accordance with NEC 310.108. And this is a model for the house wiring. We can consider normally in a general house, we used to have a sit out and then a hall followed by a kitchen with a service room. And on the other side, we may have bedrooms, attached toilets, etc. So in each rooms, we know how many lightings should be present depending upon the size and the area of that particular room, and the necessity of adequate air conditioning effect. That is, it may be a fan or an air cooler or an air conditioner, whatever it be. The entire room should be sophisticatedly be comfort for any human being to accommodate in the room. In such a way, the number of appliances has to be calculated, and then appropriate wiring conditions has to be made. That is, the number of sockets and number of switches has to be adequately designed. Thank you.